This is the Mermaid City Suite. It is a 400-year historical odyssey, mapped, composed, and rendered as a continuous, multi-sensory experience. There are no human musicians playing these instruments, and no animators keyframing this footage. Every lyric, chord progression, and visual transition you are experiencing is engineered by multimodal AI pipelines. The computational load required for this synthesis is massive because the source material is immense. We are processing the documented history of Norfolk, Virginia, tracing its evolution from a colonial seaport to a global military center. The pedagogical challenge lies in the nature of archival data. Digitized property deeds or population ledgers are static and difficult to process, which often prevent them from resonating with modern students. By utilizing artificial intelligence as a synthesis engine, we can translate that raw historical data into precise musical theory mathematics and dynamic video art. For educational technologists, this shifts how students interact with the archive. We can convert passive reading material into high-retention, multisensory environments. To understand how this conversion works, we can freeze the suite at a peak aesthetic moment and begin reverse engineering the architecture. This node graph illustrates the pipeline's three computational layers. A single historical input splits into lyrical structuring, musical mathematics, and visual rendering. We will trace these branches backward, from the artistic output to the original source. That starting point consists of raw, primary source text, digitized library holdings, 17th century colonial deeds, and quantitative casualty records. The engineering challenge is mapping the nuance of human history to strict mechanical rules, mathematically forcing the algorithm to translate tragedy or triumph into specific musical chords and visual metadata. We can start with the lyrical layer, using the 1682 foundational purchase of Norfolk Town as our first test case. This is the raw data fed into the system. It contains specific required variables: the seller, Nicholas Wise, and the exact purchase price of 10,000 pounds of tobacco. This visualization shows a large language model taking those unstructured archival facts and conforming them to a structured rhythmic framework. The algorithm applies constraints for meter and run, forcing the historical variables to land on specific musical downbeats while maintaining semantic accuracy. Standard AI text summarization simply condenses information. Generating lyrics requires the system to weigh the phonetics of words against the mathematical divisions of a musical measure. The system anchors the names, dates, and economic figures inside the meter without compromising the facts. This semantic compression converts a 17th century property deed into a rhythmic unit where critical variables are anchored to the meter. Moving to the audio generation model, we rely on a process called sentiment analysis mapping. Our second historical case study tests this process against a mass casualty event, the 1855 yellow fever epidemic in Norfolk. This chart shows the AI calculating the deeply negative semantic weight of the text. The algorithm uses this score to force a minor key and dissonant frequencies. To match the weight, the system drops the tempo, assigning a low beats per minute parameter. When the model processes terminology like fever and graveyard, it triggers specific harmonic choices, prioritizing low-end acoustic instruments over bright synthesizers. The resulting auditory mathematics generate a dark visual output, perfectly representing the minor key tonality and the severely reduced tempo. Traditional educational videos often apply arbitrary pre-recorded background music over historical narration. By mathematically linking the tempo, key, and instrumentation directly to the sentiment of the primary source, the pipeline creates an auditory experience derived directly from the tragedy. The algorithm responds inversely when processing historical triumph, as seen in our test case on the 1959 integration of Norfolk Public Schools. The text fed to the model details the Norfolk 17, a group of Black students who successfully integrated the city's all-white schools, overcoming intense societal friction and political massive resistance. The AI calculates the sentiment vector for this narrative as highly positive, characterized by breakthrough and forward momentum. Looking at this MIDI roll chart, we see the mathematical translation of that triumph. The AI generates ascending melodic steps and shifts into a bright major key. Simultaneously, it accelerates the BPM, increasing note density to physically mirror historical momentum. If we compare the values of this 1959 integration stanza against the 1855 epidemic sequence, the computational contrast is absolute: high tempo versus low, and major key versus minor. The mathematical output of the sequence has been forced into a direct auditory alignment with the historical narrative. The final layer of the suite translates this established auditory mathematics into immersive video art. Our aesthetic target for this layer is the vibrant, mid-century urban landscape of Norfolk's downtown core. To render this, we utilize audio-reactive latent diffusion. This split-screen visualization shows video generation mathematically locked to the audio output. Specific audio events drive real-time rendering. A spike in a high-frequency band, like a cymbal crash, instantly triggers a burst of luminance and vector movement in the video frame. The amplitude and the BPM of the music rigorously dictate the frame-by-frame progression of the diffusion model, eliminating the disconnect between sight and sound. The resulting render is highly synchronized, with every pixel shifting in time with the rhythmic pulse of the history. Coupling the lyrical narrative, the auditory math, and the visual aesthetic creates a dense stream of synchronized data designed to command student attention. When we combine the lyrical structure, the musical math, and the audio-reactive video, we can observe the entire pipeline functioning in real time. This is the Mermaid City Suite in its completed form. Looking at the underlying data for this frame, we see the archival source text dictating the musical key, which simultaneously drives the video prompt vector. The system delivers archival data through a synchronized stream of narration, musical tone, and visual movement. Archival research from university special collections confirms that leveraging creative media allows students to engage with complex histories through disciplined inquiry. The pipeline is designed to be accessible to pedagogy specialists, providing a modular framework for building these environments without requiring manual adjustment of the underlying code for every render. This algorithmic pipeline allows technologists to become orchestrators of history, engineering immersive learning environments for the next generation.